T-score on the first problem. On the candy problem, you should have used the T-score. Totally.
Well, I also studied for 6 hours yesterday.
If you didn't, that's just one part of the problem, so don't freak out. You don't lose 80
If you did
points.
the second problem with the wrong part, are you gonna mark it off?
With the wrong part, what do you mean?
So there's the second part. Say you were supposed to use a T-score, but you used a Z-score.
Oh, so I only take points off for the immediate mistake. If you do everything correct after that, you don't lose any more points. I don't know have you guys picked up on that? Maybe you haven't made that kind of mistake yet.
Yeah.
If you make a mistake here, you lose points for that mistake. If you do everything else right, you're fine. You only lose points for that one mistake. Okay. Doesn't that make sense? That's why you don't use scantrons. Scantrons do not belong in mathematics. Scantrons mean lazy teacher is what they mean. Yeah, did I start that? Yeah, lazy. Okay. So, we got a little bit of discussion to get into the last part of chapter 9. Everybody? This one? Okay. Any questions from homework stuff first, before I get into my rant for the day? You guys know we voted to stop changing the clock? Basically?
That's so stupid.
I don't care. Like,
So, are we gonna go back now?
huh?
So do we
So we're gonna stay on daylight savings time.
forever?
Is what it is, yes. So to be honest, I don't know what that means immediately.
But does that start as of now?
Yeah, and they basically said they're going to do it. So it was basically a vote to stop changing. I think daylight savings time, believe it or not, ended. So we're currently not in daylight savings time. So I think we're going to switch one more time and then, yeah. So I think we're going to get to fall back one more time. Yeah. I mean, spring forward. Spring forward one more time. Say again?
How's that going to affect business?
I don't know. Probably not. It was enacted way back when. And then things like that need to be analyzed again when things have changed quite a lot. So things have changed quite a lot. I don't know where you personally feel about that, and I'm not really sure why you would, but I always thought we should just change it by half an hour and then stop, right? Just split the difference so nobody's happy. That's the best way. Okay, there's a lot of other shit on that. I don't know if you guys voted, but it was like a two-parter. It was huge, right? But yes, it always
It was
is.
like vote no to keep
Yeah,
help dialysis patients.
a couple of them were
I'm like,
so
what?
evil.
Well, I work.
You got to be careful. A couple of them were worded so that it sounded on the surface like one thing, but if you looked into it, it was completely something else. So what I normally do is I read it myself, and then I go to several different things to see what their analysis is and what their recommendation is, and somewhere between all that stuff you get the truth. And that's how it works. That is how it works. I mean, do you guys know there's a statistical bump if you're listed first? People will go and have no idea, go, I vote for you, vote for you, vote for you, and look at me, I'm a good American. You know, and it's like, if you get placed first, there's a lot of they're like, want to know the rules for what gets you first, and they're pushing, let me put myself first, because they know they get like a 2% bump from just being first. So the order of stuff matters. The wording of it is haggled over like crazy. The wording, and some of you guys pointed out, the wording is sometimes very like, what the shit just happened? So if you did vote, good. Hopefully you actually analyze things a bit. They give you that voter guide, right? Okay, we'll see. Okay. So any questions from homework stuff? Questions from homework stuff? No. Okay, I'll take this as a no. So today we're going to do hypothesis tests for percentages. And this is related to the quiz you guys just took. If I'm doing an NPQ problem, right? Like number 2 on the quiz, the one about voting. What do I check to see if it's normal? Check for no. normality, NP and NQ have to be,
Over than Yeah.
oh shit.
Oh, do you mean that's over?
Like I knew them and I didn't.
When do you check to see the sample size is bigger than 30 if you have what kind of problem? Not a percentage problem. When you have a mean problem. Some of you guys are like, they're all mean, Jeff. No, but a problem involving means. Then you have to check to see if n is greater than 30. A problem involving percentages, guys, it kind of makes sense that they have to incorporate those percentages in the check, not just n. So that's when you check this. Okay. Maybe. So the steps of the test for a percentage will be the same as the steps for the means. It's just that step 2, am I allowed to use z-scores or not? You got to check this. And I don't know if you guys, all right, I don't know if you guys realized, there's this formula, right? I'm pretty sure I've said this before. This formula, and then you got this formula. That's all the ones for creating confidence intervals, right? Do you notice how it's when you're dealing with means that you might use a z or a t? What do you use when you have a percentage? If you could do anything, you always use a z-score. Either it's normal and you use a z-score, or it's not normal and you don't do shit. So for a percentage test, if I said, I think that 30% of Grossmont students didn't vote, right? And I want to check that out. That's a percentage problem. I'm going to have to check NP and NQ. And I'm never going to use t-scores for that problem. I can either do it and I use z's, or I can't do it and I don't do shit. So that's the one difference, is on step 2, I'm not looking to see if it's greater than 30. I'm looking to see if this is true. Right, this is step 2. The other big difference is step 4 is where we calculate z star. Remember? So step 4, I can't use this formula because that's for means. Okay, so I've got to use something different. Stay with me now. I've got the formula up there. Which of those confidence intervals are for percentages? Last. What's the standard deviation in that equation? Where is it? See, this is the standard deviation for these guys, right? So what's the standard deviation for NPQ problem? That. So watch this. This is, please, dear God. Remember I said this before, and you guys might think I'm crazy, besides apparently suicidal. I said z-score formula never changes. It's our data. In this case, our data is going to be p hat. That's what we get from the sample. Minus the population stuff, p without a hat. Our data minus the supposed middle, the actual population stuff, divided by the spread, which in this case is this dude. So the steps are all the same. You still got to set up your hypotheses. You just got to check to see if it's normal. You still got to set up a rejection region. You still got to make a z star. Beep, beep, beep. And then you still got to have a conclusion. All the steps are the same. It's just that how in the world would this work with percentages? There's nowhere for percentages to go.
Is it p hat, q hat?
I love it. Okay, that's the next thing. We had this discussion earlier. If you know S and you know sigma, which one are you going to use? Sigma. If you know p hat and you know p, which one are you going to use? P. Why did I have to use p hat, q hat for this? Because in this example, in this problem, I don't have a freaking clue what p is, what the percentage of the population. I don't have a clue. So I have to use these. Over here, I'm assuming I know what this is. I think less than 75%. Okay, then p is 75%. I take a sample. Let's try a problem out. So the two big changes are, this is what you check for normality. We knew this. This is the new thing. This is the z-star formula for percentages. You guys love it. I don't care. So, I really hope to God you understand a little bit what I mean by the z-score formula never changes. It never does. Our data minus the middle divided by the spread. Z star is the z-score we calculate. Right. Remember, I put a little star on it to separate it from the critical z-score, how far away I have to get. Does this all sound vaguely familiar? That's the only reason crazy-ass Jeff, puts a little star on there, okay? If you don't want to put it on there, don't. You say, nah, Jeff, I don't want your star. It's fine. Okay, let's try a problem out. I'm used to oppressing people, but you guys seem really, really extra oppressive. So there you go. Let's try one. So let's say we talk to 714 people. And let's say 685 are happy. The elections are over. Well, I've experienced the feeling. Have you ever experienced the feeling where you're like, I might have sucked on the test, but thank God it's over? All right, I've lived that experience. I'm like, oh man, I think I did bad. I don't care. It's just over. So thank God the elections are over. This is all I got to say, right? And then I want to test the claim. Test the claim that, let's say, let's say less than, oh, now you got to do this, Jeff. Less than, let me do this real quick. Make a claim that makes sense. Yeah, all right. Less than 97%. I feel that way. Like it. All right, how we doing? So that sounds very hypothesis testy, right? It's got this claim sitting there. So what's the first thing I do? First thing I worry about, and the last thing I worry about, is the claim. What's the claim that's being made? Yeah, so now make it mathy. Are we talking about means or percentages? Percentages. So the claim that's being made is the percentage is less than 0.97. Good. Percentages are a representation we completely made up. So always use the actual number. So which one is that? The low or the high? I love the people that have not been to class in a while. They're sitting here like, what just happened? No, it wasn't, of course. Yeah, quiz is over. We're doing new shit. Sorry, Joe. Yeah, this is chapter 9. Yeah, quite done with it. How many tail tests will it be then? One tail test, 11. So see, I mean, it really isn't that different. There are two things that we talked about that are different. But it has the same feel. So if you really hate them, I'm sorry. This is the same. So it's a one-tail test. So what's the next step? I would tell you, define the rejection region. Using alpha equal to points, let's say 0.05. Did I write that particularly bad? Is that what it is? I see a bunch of interesting. Define rejection region using alpha equal to 0.05. Looks fine to me, but you know. I see my writing a lot. Yes?
Wait, how do you tell whether it's a one-tail or two-tail?
Where's the place that evidence would show up? What's the only way to have evidence that it's less than that? It's got to show up down here. One tail. If I thought that it was different, then it could be either up or down. So when you have a direction word, that's going to be one tail less than. We think it's increased. We think it's gone up. We think it's gone down. We think fewer. We think more. You know, directional symbols are going to be one tail tests in that direction. That makes it so much easier.
Is every car going on? Their cars. They're fun. More than one.
So nice. Out here in the compound. I'm trying to call this the village. I call it the compound. The village, yes. This was called the village.
Why do they put it out here? Do you know the
That's so
reasoning?
It's
for-
just the biggest spot of land that they could have all these
Yeah,
together.
but they stole so much parking. This was valuable parking.
All right. I'm stuck in the damn office. I'm not gonna be on your side too much. How do I find this? And by the way, I'm doing one step too soon. That's step C. Step B should be, is it normal enough? And we use Z-scores. What do I check? I check NP and NQ. What's N? 714. And what's P?
6, 8, 5.
No.
And so.
What's P? 0.97.
97.
So that'd be 714 times 0.03 down here. So again, when you do a hypothesis test, we're assuming that P is 0.97. We're assuming that. So I know P without a hat. So I'm going to use it. So help me out. Somebody got this for me? Surrounded by calculators. Yes?
692.5.
692.5. That's bigger than 5.
No, 0.58.
5.8? Sure.
Yes.
And then this will be 21.42.
Yeah.
Greater than 5. What's that mean? What's it mean that NP and NQ are bigger than 5?
That's normal.
Normal enough. I like it. So we're allowed to do something. If one of those was less than 5, we actually could stop right there. Yes?
Maybe equals 5?
Yeah. I think, depending on the textbook, I think this one does have an equal sign, but they're still way bigger than 5, so what the shit? We're good. Now coming back to this guy. It's a Z-score, but of course we're going to look at the T-score chart. It's a one-tail test, 0.05. What do you guys get for the Z-score?
One 6.5.
Yeah, and in this case,
Minus.
negative. So we're the humans.
Yeah.
Chart's just going to give us a number. We're the humans. We've got to know if it's negative or positive. Draw the picture and you'll see it's negative. It's down here.
It's negative.
How do I put this in words then? If Z star, how do I get into the rejection region if Z star is less than negative 1.645? What can we do? Reject the boat, support the high, which several states did yesterday. At least the support the high part, yeah. Okay. So it makes sense right after defining what far enough away is. So this is far enough away. My claim is it's less. It's very easy to get something that's not this, even if this is the real percentage, because I'm taking a sample, so it's going to be different. So not only does it have to be less than this, it's got to be a decent amount less. What's that mean? Well, in this problem, it means this many standard deviations less. Really want that to make sense. It's that whole idea of if I said, I think that guy over there is 68, and we ask him, and he turns out he's 67, you're going to be like, you are so wrong. But if I'm like, I think he's 68, and he's actually 41, you're going to be like, holy shit, dude. You're wrong. So it's that whole idea of not only, if I feel a certain way, not only do you have to show I'm wrong by being a little different, you got to show I'm wrong by being a lot different. And this is the measure of how different is enough evidence. So then the very next thing we do is, how freaking far did our sample get? So what do we know from the sample? What's p hat? What's p hat? I always love how people have so much trouble with percentages nowadays. What's p hat? Where'd it come from? Okay, so 685 out of 714. 685 out of 714. So you get what now?
0.96.
959. So remember the thing I said a while back. So these have to be at least 3 places. If you make everything at least 4 places, you're golden for this class, right? That covers everything. Standard deviations have to be at least 3. Probability has to be 4. Z-scores have to be 2, but it's not just because the chart only goes 2. Okay, so now I can do my z-score formula. Here's the z-star formula. P hat minus P divided by this business. So it'll be my stuff minus the supposed middle, 0.97, divided by, what goes in here? The square root, what goes in there? Yeah, and P is 0.97, Q is 0.03, and N was 714. It's always the bigger number, because that's the total. Thank you. Oh wait, it's still going.
Yeah, you weren't on. You're not recording yourself.
That seems like it would be useful. So take a minute and try to calculate this. Don't forget, and don't forget here, make sure the whole thing is under the square root. Right? Let's see what we get. If you get negative 1,048, you probably did something wrong. That's so awesome. Sorry. I wish I could claim that I tried to do this on purpose, but I didn't. You should get something reasonable. What are you guys getting? Negative 1.72. That's what I'm getting too. Anybody get something wildly different and wants to let me help them? No? Okay. All right. And what the hell does that mean? What shit's that mean? We got into the what? The region. We got into this rejection region. There we are, right? That's another reason why I call it Z-star. Because it's a cool star. We made it into the rejection region. Why do we call it the rejection region? I forgot. Well, no, I didn't. There it is. We call it rejection region because that's when we can reject the whole, the null hypothesis, right? So right here I can say, reject the null. Support the high. So can somebody find the p-value for me? The p-value. Can you guys find the p-value? What's the value of p? So how do you, what is the p-value? P-value is the area in the tail that our z-score makes. You just have to look it up on the chart. So look at negative 1.72. I'm catching up to some of you guys. 0427. What was the alpha again?
0.05.
The alpha was 0.05. Do you see if the p-value is less than alpha, it's a smaller tail, therefore I would reject the null n2. So I can either compare z-scores or I can compare areas. If my area, my p-value, is less than that, then my tail must be smaller, meaning I am further away. So both ways of looking at it agree, thank God. Did we beat this test by a lot? No, we're really close. I mean, we're really close. But we made it still. That's all that matters, really. So how would I word the conclusion? What was my claim again? This is the only other time I worry about my claim is at the very end. Which one was my claim?
That is less than.
Yeah, the high was my claim, right? So I want to use this language. Forget this language. Get away. Go away. Everybody has trouble with that last step. How do you know to say reject or support or what? What's your claim? You use that language. So did we make it?
Yes.
Yeah, so we have found sufficient evidence to support the claim. That what? Support the claim that less than 97% of people are happy the elections are over. Okay. So you can imagine if you have a household cleaner that kills 97% of germs, and you're like, I think my cleaner kills more germs. You could do a test. You can take a sample. You can do stuff, and then sample this and see how many bacteria are still alive and all. You guys with me? And this would be evidence for or against that claim. That's the immediate use of this. Okay, so here, I want you guys to work on these problems. How did they? So we came up with this number. How did we?
Why did you pick 0.05?
I didn't. How did we come up with this number? I didn't pick this shit. The alpha is 0.05. We can use z-scores, right? Alpha is 0.05. How many tail tests? 1. If you look at the t-score chart, 1 tail, 0.05, all the way down. Is that cool? If it was a 2-tail test, I would have looked in the row below that. Yeah. Cool. I like it. Please feel free to work together on this. It's up to you.
Oh, what do you do today? What do you make
Here. That's good.
Oh, I thought you had to.
Yeah. We assume that that is correct. And we're trying to show evidence that it
It's
isn't.
like a restaurant. We're gonna go.
So the thing in the claim is what we assume is right. This is how the one we get from the sample, that's why it has a half. That's the one.
He was a very single man last night.
No.
I
So
told him.
here it is 0.05. Here it's 0.1. So, but that's just these. So
So the claim is that at least 20% of Americans play soccer.
If you stop, you get a T-score.
Claim is
Go all the way to the bottom. What score would you say we could use? See, that's it. If you stop, you get a T-score. All the way to the bottom. This is
1.2. Okay.
It's a percentage problem to know. But in general, if it was a T-score problem with 714, then all good plus
Okay, so like always imagine the mouth eating
on this chart.
whatever is greater. Yeah. If something's greater, the monster is eating whatever is greater.
You have added one.
So
He's got to be less than one.
Whatever the hoe is, the high is
Look at 80.
Yeah, right, so the opposite is the sign change.
Just like this.
I'm in love with this paint, honestly. I'm in love with it.
It's a one-tail test, right?
Oh, I see.
So
Yeah.
it
Here we're
says it
talking
could be
about
both ways.
Yeah.
Yeah, so it has to be a one-tail test. Because a two-tail test, he said, is something like if you could go either way.
No, you're fine. Just,
If it's
you
different.
won't get a zero because you won't get whatever you make on the next test.
Oh, it's
On your
not.
place. So your next test is effectively called.
Oh, if it's equal to, got it.
Oh, I'm recording this. This is awesome.
Till we got the rate of